Today we're going to finish up our notes on Chapter 6. So we're going to start with the bottom of page 8. You only have the last half of this page to finish up. So we're going to talk about adding terms of a geometric sequence. Remember we talked about geometric sequences yesterday. The geometric sequence means you keep multiplying by the same number to get to the next, and it has an R value. R is the ratio of the second term divided by the first term, or the ratio of any two consecutive terms. So if you add up these terms, like if I want to add up the first 20 of these terms or the first 500 of these terms, it's called a geometric series. So series means you're adding up some number of terms in a sequence. So here's a formula for you. If you want to know what the sum is of the first n terms, like the first 9 terms or the first 20 terms or whatever that n is, you can use this formula instead of having to add up a whole bunch of numbers. Many times it's a lot faster to use this formula. You don't have to memorize this formula because I'll always give it to you on the reference sheet. But if you want to use this formula, you need 3 things. The first thing you need is the first term, because this S means sum. And this N means of the first N terms. And this R is the ratio. So you need the first term because it's in this formula right here. There's A1, that's the first term. So you're going to need the first term. The second thing you need is the R value, or the ratio. And the third thing you need is the N value, how many terms you're trying to add up. So once you have the first term, and the first term is called A1, once you have A1, add R and N, all you have to do is substitute it in this formula and you can figure out the sum. So this is how it works. We're going to sum the first n terms, and I'll give you n, it's 12 or 9, or we're going to figure it out down here, of these geometric series. So you don't have to even determine if it's a geometric series or not, I tell you that. So here's a geometric series. It looks like you're going to multiply by the same number each time, and we'll figure that out. So remember, you need 3 things. The first thing you need is the first term, and the first term is a 2. The second thing you need is the R value. The R value is the second term divided by the first term, or any 2 terms divided by each other. So R is 8 over 2. Which is equal to 4. Remember, just if I tell you it's geometric, just take the second and divide it by the first. That's usually the easiest way to get R. And then the last thing you need is the N value, and I tell you what N is. So N is equal to 12, and that's all we need to substitute into this formula. So the sum of the first 12 terms of this geometric series, you could add them up in your calculator if you wanted to, but it's probably a lot faster if you just plug in the formula A1, which is 2, 1 minus R, which is 4, to the nth power, which is 12, all divided by 1 minus R. So there's the sum of the first 12 terms, and we can just put this in our calculator now. Please use the fraction button. So the fraction button is the alpha y equals option 1, 2 times 1 minus 4 to the power of 12, all divided by 1 minus 4, and that is a pretty big number, which we would probably expect because these numbers are getting very big very fast. So let's write that down. That sum is 111,84810. So it's 11,184,810 if you added up the 12 terms here. Number 2, you need the 3 things. You need the first term, which is 1. you need the r value. R is the second term divided by the first term, which is -6, divided by 1, which is just -6. And the third thing you need is n, and I tell you n is equal to 9. So you can put all those together in the sum formula. The sum of the first 9 terms is the first term times, and we're just using this formula here, 1 minus r. I'm going to put, because it's negative, I'm going to put -6 in parentheses. You should always put negative numbers if you raise it to a power in parentheses. You raise it to the 9th power, and you divide that by 1 minus r, which is -6. Or you can just say 1 plus 6 if you want. So let's do the alpha y equals option 1, 1 times 1 minus -6 raised up to the 9th power, to the 9th power, all divided by 1 minus -6. And there's another pretty big number, 1,439,671. And then the last one. The last one gives us this geometric sequence, it seems, or series, it seems to be going down. The first thing you need is the first term, which is A1, which is 8. The second thing you need to know is what the r value is, and the r, remember, is the second divided by the first, which is 4 divided by 8. R is equal to 1/2, or if you want to call it 0.5, you can. It doesn't matter. And then the third thing you need to know is what n is. And I don't tell you what n is. I just give you these 3 dots, which means there are some numbers that are going to go in this blank. And we have to figure out what term this is. What is the n value here? What term number is this? Well, what I would do is I would write this out. 8, 4, 2, 1. And if you notice, we've already noticed that they're all being times by 1/2 times 1/2 times 1/2 multiplied by 1/2. So the next one would be 1 times 1/2. The next one would be 1/2 times 1/2, or cut 1/2 in half and you get 1/4. Cut 1/4 in half and you get 1/8. That's what this is. Cut 1/8 in half and you get 1/16, and then we get the number that we need. So what do we get? We can actually probably just pop this into our calculator, but I want to show you how to use the formula. So what term is this? This is the first, the second, the third term, the fourth term, the fifth term, the sixth term, the seventh term. This is the 8th term. So this right here is the 8th term. So n is equal to 8. So now when we put this into our calculator, the sum of the first 8 terms is equal to A1, which is 8, times 1 minus, r is 1/2. We're raising 1/2 up to the 8th power, and we're dividing it by 1 minus 1/2, the r value. So let's put that in our calculator. 8 times 1 minus, and I'm going to use that 1/2 to the power of 8 over 1 minus 1/2. So that's 255 over 16 if you add up all of those fractions. And it looks like we might be done, but let's do one more. Let's give ourselves a little bit of room down here. Let's do one more. Let's find the first 7, the sum of the first 7 terms of this geometric sequence up here. 1/3, 2/9, 4/27, 8, oops, over 81. So let's see what that's going to be. We're going to add up the first 7 of those. So find 1/3 plus 2/9 plus 4/27. This is example number 4, I guess, plus dot, 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 and I'm going to say n is equal to 7. Let's add up the first 7 terms of this. So the first thing we want to know is the first term. A1 is 1/3. The second thing we want to know is what R is. R is 2/9 divided by 1/3. Well, we've already done that up here, so let's not do that again. 2/9 divided by 1/3. You flip the 1/3 upside down. So the R value here, because this is the same example as 2/3, so R is 2/3. And the third thing we need to know is n, and n is equal to 7. So we have everything we need to know. So we have the sum of the first 7 terms of this is equal to the first term times 1 minus 2/3 raised to the 7th power, all divided by 1 minus 2/3, 1 minus r. So let's see what that equals as a fraction. And this is a 1/3, so I'm going to put another fraction in my fraction. So we would have 1/3 times 1 minus another fraction, 2/3 raised to the power of 7, all divided by 1 minus the fraction 2/3. Looks like that's all in there right. Let's see what we get. 2059 over 2187. And that's how you do the geometric series if you have fraction anything. And that's it for today. See you in class tomorrow.